Hey self, that's who you're talking to now because language, appearance, gravitas, we could use those words. Alright, so the mind's spinning. You can tell it's going to engage in words in a second or two here. Words with deep thought and perspective. If we could figure out how to use a video editor, we'd cut this out. So fast forward to some time out here past probably the first 4 minutes. What you're witnessing is collecting of thoughts. I suppose the word efficacy. Yeah, let's play with that one. So, efficacy is how good is it to do something, right? Is it appropriate to do something? So if you try to make the word an absolute, you miss the meaning of the word, because it's a relationship between good and bad, the amount of harm versus the amount of good. So it's a weighted decision. It's not an absolute decision. You can come to a binary conclusion, but it's still an analog answer. So it's within a range of possibilities, right? So, efficacy. How well does what you're doing match what you're trying to do, right? So, in order to assign efficacy is a weighted measure. How do you find the value of that weight? Oh boy. So, let's go into a Venn diagram maybe. Simple Venn, 3-ring circus, but each one of them has elements in common. So how much does the first ring overlap the second ring and overlap the third? Okay, they're on the same lot. So they have shared resources in the hot dog stands, in the parking lot. So there's some intersectionality there, and those 3 circles should show some overlap for it. Now the hot dog stand for A and the hot dog stand for circle B may not be convenient to circus ring C, but it's still there. You have to walk further to get to it, but maybe the restrooms are over that way, so it's getting more traffic. So my intersectionality is growing. At some point, because of that, those 3 circles touching each other like the Olympics start to turn into a circle. Or not a circle, maybe a triangle, depending upon how good a circle you can draw, right? Or maybe it is a triangle, and you shouldn't be using circles, and you can avoid some of the intersectionality. So that simple, even two-dimensional Venn diagram, if you want to make it theism versus atheism, there's an intersectionality there that you can't ignore. You can't throw away because it's a part of you. So the bake sales were some of the most delicious pies you grew up with. At the 4-H show down the street were made by some of the best people you know. But that's your only intersection with them, is that once a year farm festival, celebration of livestock and tractors and demolition derbies, right? So yeah, intersectionality is a word in here. But I wasn't talking about intersectionality, was I? I got way off track, yet there's some weight. So we just got run into by intersectionality if you want to find a rabbit hole. And there's rabbits all over the place. They're a problem in Australia. So, bless the rabbits. It's the mushrooms that can cause the problems. All right, back on what were we even talking about? So we're back to efficacy, right? Capital E, where a noun becomes a verb. Is that the right? So, going back on things I haven't justified, but I'm still going to speak about, is measurements and efficacy. When you go to a doctor, you kind of expect to have some kind of tests done, especially if it's your yearly or whatever, even if it's a verbal test. How you feeling? How you doing? Is it getting better? Doctor's going to look at it, might touch it, right? The more analysis he does, the better you feel, because he's looking at it and he's saying, yeah, it's wise to be wary, but don't worry, because this isn't anything to worry about. So we just ran into a doctor here. How do we get off the track of efficacy anyway? But you have some expectations, right? Going into the doctor's office. You want to get better, that's why you're there. Or you want to make sure you're well. That's why you're there, because you can fool yourself. Look at me. So efficacy. On topic here, we're staying on topic. We're 8 minutes in now, so maybe you could have just come here. Who knows? Why'd you come this far anyway? All right. So let's do an intersectionality thing here, and let's throw measurements into this. So we just went to the doctor, visited his rabbit hole. Might have had x-rays. Well, x-rays. So you might not have. You might just be looking at your gums because you need a second opinion once in a while. You're a fool. He sends the blood work off, and it goes to a very specific lab that has licensing and accreditation and should be following a set of rules and procedures and standards that is thorough enough to be able to test whatever he wanted to test. You peed in a cup, they took blood, you spit in a vial, whatever the test was, you gave them tears. Each one of those secretions has a piece of information in it. Boogers too. Boogers tell you what you've been breathing. But nobody does a booger test. You can't afford a booger test. Would you know who to take your boogers to get tested? Or farts. The physics of fart testing. I mean, it's mostly methane, but it stinks, so it's got aromatics in there, so farts are more than farts. Or farts are more than methanes. But you can light them. And you can measure them. So, the efficacy of measuring farts. Now, if I was going to have my fart tested, I'd have to probably go to gas spectrometry. First for cost, because sample preparation can take a long time. And if I've got to change the molecules or elements in the gases into some type of solids, best way to do that, maybe freeze them. See if you can get them to accumulate somehow. You might add a reagent to get them to accumulate too, but now whatever instrument you put it into, you have to subtract reagent measurements. An acid or a base or spit, or you peed in it, or maybe some dust fell in it, so now you have yeast that grew overnight. So there's rules about how you handle the sample depending on what you're looking for. The rules, the chain of custody thing. So the people that use those instruments know very well what they should do, what their roles and responsibilities are with it, what it can do. They have to prove what it can do. So they'll do calibration or certification runs. And it might have been done on another shift. They might not even see them. It might be done automatically. They might not see it. And that's what I did, is program these things to happen so operators didn't have to get involved unless the machine broke. So okay, I selected gas sampling methodology. I could do some type of titration tests on it. Throw a titration strip into the gas vial and see if it does change color, if it racks the end of the reagents. But the titration strip probably was meant to be dipped in a liquid. There might not be enough liquid. Remember, water is one of those solvents. There's more on that strip that do things. So now we're doing titration strips, because those are one of thousands of types of measurements that can be done to answer a specific question. And this is where you get into efficacy of measurements. Okay, let's go into efficacy with one of my favorite topics, Geiger counters. So what exactly is that Geiger counter saying? It can't talk unless you programmed it to talk. It's not saying anything. It is a relative measurement that has a lot of relatives. The relatives are isotopes and particles that are not part of normal chemistry, because their effects are understood and accounted for at a macro level in equations. So what did I just say? Multivariate analysis. All right. Wow. So the physics of an instrument exactly define what it can do. You can't bring a voltmeter to a nuclear accident unless you know what you can do with that voltmeter, because it could tell you something. I could give you some hints how it could tell you something, and it's MacGyver stuff. Give me a soldering iron. But for that, I don't need a soldering iron, because that little multimeter sitting there can do things beyond what you think it, or what you understand it can do. So on the measurement spectrum, specifically in elemental analysis, probably the latest instrument no one's familiar with is an E-TIMS machine, small e, capital T, IMS. It uses mass spectrometry. It is a destructive form of analytics, meaning you have to get and prepare a sample to go into the machine. So right up front, you have some high-resolution chemistry to even stick your finger in the machine to load it. Once you've loaded it, it has the ability to analyze what it has the ability to analyze, which is defined in the detector resolution of each detector and separation physics to the detector. Its stability, basically how good it is. We're counting parts per billion. One drop from an orange. What's in one drop from an orange? Or a grapefruit? Or one drop from the sun? What's in one drop from the sun? Could we even get a drop from the sun? Do we get a drop from the sun now? Can we look at that drop and know where it came from in the sun? And hint, all of it comes through the surface or from the surface. So it's a relativistic absolute. All right, I'm at 18 minutes now, which is a few minutes past my babble time. If you can't see 7 different questions to ask or Google, I have failed miserably. And maybe you understand why this wasn't meant to be released, but I probably will. I don't like the background. I'm not chewing a Good and Plenty this time, which has some positive attributes, so. But don't discount the Good and Plenty wasn't a prop either, so. In multivariant analysis, I'm a progressive. Have a good one. It always is.